Welcome to Containerized Conversations. I'm your co-host, Jesse Caffarelli.
And I'm your co-host, Josh Warhurst. Hey,
Awesome.
Jesse, what are we doing today?
I found an article that I sent you. I said, hey, this article looks pretty good. Let's talk about it. Spoiler alert, I may not fully agree with, but I think that's what makes it a good article to read.
Yeah, I think any good article is a combination of agreeing and disagreeing. If you agree entirely 100%, then you're probably not thinking critically. So if you haven't read it, it's from the New Stack, and the article is called Why CI/CD Alone Won't Cut It for Infrastructure as Code. And I think we have a lot of thoughts on this already, but that's what leading titles are going to do.
I'm actually, I was going to say I was only going to interrupt when I had something to say, and hopefully it wasn't too much, but I'm already interrupting.
That's a good place to
Now,
interrupt.
so I've had experience working at multiple places, and I do have to say, I've worked at some places that do CI/CD for their infrastructure, but I've worked at even more places that don't.
Mhm.
So I have always thought that CI/CD is like the Zen garden. It's the perfect place to get to. Doing unit tests. So, specifically Terraform, right? A lot of the places I've worked at either has Ansible playbooks or Terraform. Now, we've worked at a place where I very much pushed Ansible as a way to kind of test our Ansible code through unit testing.
So you're
I
saying
thought,
use Terraform as a way to test Ansible?
well, no. I forgot what we used, but we used some sort of Python package.
I was thinking Molecule was a way to
Molecule,
test.
yes.
It did use Terraform to spin up
Okay,
environments to run
a
against.
little bit, yeah, a little bit. Which, at what point do you test your testing framework?
Yeah. Who tests the test man? Yeah.
So for me, like I was diehard into it, right? And so I was introducing it into our team. It was your kind of first experience. Did you find it helpful? Did you not find it helpful at all?
First, I think we can certainly do a whole episode on CI/CD alone.
That's true.
And we should get to it.
But specifically for infrastructure as code.
Yeah, no, that's a good point.
You can say, Jesse, it was actually terrible and slowed us down. I will not be insulted.
No, I don't think I can say that. I'm a big fan of CI/CD. I think what this is saying, this title already, why CI/CD alone won't cut it for infrastructure as code. We all agree that CI/CD is better, right? Not having CI/CD is kind of like not having unit tests in your code. You can write code that works perfectly well and has no unit tests.
Yeah.
But you're going to be a lot safer as your team grows and expands and as people come in and out with something like a CI/CD pipeline that will make everything standardized, simple. You can read it. Although I think readability is something that a lot of CI/CD pipelines struggle with. But I don't think this article to start out with is saying that CI/CD is bad at infrastructure as code.
Yeah.
I think it's just saying, again, just from the title, that CI/CD alone isn't everything. You need to think beyond there.
Yeah.
So I'm a big CI/CD fan. I think that it's kind of like Kubernetes, though, where there's going to be people that will go and say everything should be Kubernetes, right? And I think it'll be an it depends kind of case. But I guess we'll see as we get through the article.
So yeah, sorry. Continue.
Well, let's see. So why CI/CD alone won't cut it for infrastructure as code? As infrastructure grows in complexity, I'm reading from the article now. As infrastructure grows in complexity, relying solely on CI/CD leads to drift, bottlenecks, and breakdowns. Dedicated orchestration is the next step in IAC maturity. This is an article from May 29th, 2025 by Marcin Wyszynski. Let's be honest, infrastructure as code, IAC, was supposed to make everything easier. And for a while after you start using it, that's what happens. The first time you swap manual provisioning for Terraform or Ansible, it feels like magic. No more clicking through cloud dashboards. No more who made this change mysteries. Everything is version controlled, repeatable, and, in theory, collaborative. But at some point, the honeymoon ends.
I do really agree with that paragraph. And I think one other thing that it doesn't mention is CI/CD gives your team the ability to empower your more junior engineers, or not even just junior, but less familiar to the code-based engineers, to freely make changes and feel comfortable that they're not going to blow up something in production.
Right.
You did say that a little bit at the beginning, and I think that's honestly, if you're sitting back and you're going, well, we don't need CI/CD, I'm a pro at this. As long as you write good code, you don't need testing, you don't need to be automated deployment, but that's the problem. It would be just you.
Which some people are fine. They have a clear career path that they're planning to spend the entire time at this one company. And but even when they have that plan, it doesn't mean the company has that plan for them. So your infrastructure scales, to continue with the article, your infrastructure scales, your team grows, and suddenly that neatly organized IAC repo turns into a sprawling, interconnected mess. Engineers start stepping on each other's toes. A single typo in a shared module can take down production. Don't ask me how I know. Your DevOps team becomes a bottleneck instead of an enabler. And here's the kicker. This isn't just your team's problem. In a recent survey commissioned by Spacelift, 45% of organizations believe they have a high level of infrastructure automation, but only 14% do. There's a huge gap between perception and reality. Companies think they're operating at a mature level, but in practice, they're still running into the same pitfalls: inconsistency, governance struggles, and the classic trade-off between speed and control. So how do you know where you stand? And more importantly, how do you level up? So the next section is the 4 stages of IAC maturity. One thing I just want to mention with that first section, that difference between the fact that 45% of organizations think they have a high level of infrastructure automation, but only 14% do. I think that feels right. For a CEO, they're probably sitting in all the high-level C-suite people. They're like, oh yeah, everything's all automated. But then when you talk to the people on the ground, they say, well, it's all automated, except that, yeah, Jerry does this and Monica does that, and it's all a big mess.
Well, from what I've seen too, is it's always tied to some sort of timeline. They're convinced that, let's say, spinning up a production site from nothing to ready, in their minds, it only takes a day or even, a week. But in reality, it's always at least 3 times that. I've seen in the worst case, people tell me, oh yeah, it should only take you 1 or 2 days. And then 3 weeks later, I'm still going to multiple teams trying to figure out how to get the thing up and running. And to their point, some of the pieces are automated, but they're not really automated together.
Yeah, well, that high level of infrastructure automation, I think, is also a nebulous term that means different things to different people. It's kind of like somebody who says, oh, I'm not a picky eater. I eat everything. And you're like, well, do you eat bugs? And they're like, well, no, I don't eat bugs. And you're like, well, then you're still kind of a picky eater. I think the idea of high level of infrastructure automation is just something that is going to differ from company to company. And some people says we have one Ansible script that sets this server up, and so we have a high level of infrastructure automation. No, you have nothing, but you have a perception of high level of automation. So anywho, the next section is the 4 stages of IAC maturity. So infrastructure automation isn't binary, it's a spectrum. Some teams are just starting, while others have built robust self-service platforms with guardrails and automation-first workflows. To map this out, we use the survey results to build an infrastructure automation leadership index. It breaks maturity into 4 stages. 1. Experimenter. You're testing the waters. Some automation, lots of manual workflows. 2. Adopter. You've committed to IAC, but standardization is a challenge. 3. Optimizer. You've streamlined deployments, but gaps remain in security, compliance, and scalability. 4. Leader. Infrastructure is fully automated, self-service is the norm, and security is built in. Most organizations fall somewhere between adopter and optimizer. They've seen the value of IAC, but they're struggling to scale it. And this is where IAC orchestration comes into play. Any thoughts there?
I mean, honestly, I really love the 4 stages that they mention in this part of the article. I honestly can see a lot of the companies I've been at kind of fit. The problem is they kind of fit in between some of these stages too.
Right.
My problem is that like leader part they add in and security is built in. I've seen a lot of companies really try really hard to have it built, but I don't know if I've necessarily ever worked at a company that successfully did it. especially if you're talking about CI/CD, right?
Sure.
Security in production, 100%. I truly believe in that. Having it within the CI/CD pipeline, I've only just started recently seeing that at some of the companies, and not to name drop any companies, but I think Sneak is the person who is really killing it in that sector.
Hmm.
It really does enable you to add it in as part of your CI/CD pipeline and build it in. But before that tool was out, because that, I mean, I guess it's not like a completely new tool, but it's within the last few years. Before then, it was really hard to do that. Really hard. The leveling, I almost feel like you should break it out into some sort of matrix and involve security in as like a whole nother 4D rating system.
Sort of the difference of DevOps and DevSecOps, or
Yeah,
I do.
exactly.
There are a lot of companies that these are like high level categories,
Mm,
right? In history, the difference between first world countries and third world
yeah,
countries, it's a
yeah.
huge spectrum. There's not really, we have these concepts, and that's a Cold War concept, but we have these like these different stages here that we're talking about. And you're going to find a company that security is really important to them,
Mm,
and then they're still having manual workflows, right? They make steps 2 and 3, adopter and optimizer, quite a big range.
yeah.
Experimenter, that's pretty quick. I think a lot of companies will move from the experimenter to the adopter stage very quickly.
You'd be surprised. It does. It really depends, right? Is just one team doing the automation, or is it the entire company? Because if it's just
Mm,
one team introducing the automation, it could take a very long time for a company to grow from 1 to 2.
that's a good point. I know that time frame can be different for different companies, but usually when people see the power of ISC, they commit pretty quickly. But actually, even with the company we both worked at, you had some teams who moved very quickly from like experimenter to adopter to optimizer, and other teams who, in that same time period, did not move forward,
Yeah,
right? As an organization, you can't say, like, yes, this one team over here has got everything perfect, but this one other team, they're still manually building artifacts and sending them to a QA engineer over Jira, right? That's not that's not how you do things. And so how can you categorize the whole organization if the organization is so varied over there? And I guess you can level it all out and average it in the middle somewhere.
well, and that honestly, that's a whole complete side tangent on the work of an SRE that I
Hmm.
think, like, we can definitely get into in a whole nother episode. But I actually think when you're introducing DevOps and you have like an SRE team that's tracking KPIs and maturity levels,
Hmm.
when you're first changing the organization over to DevOps, it's actually really important to do that. Your individual teams that you're supporting, you measure their capabilities to automate and their capabilities to be flexible. So there's a bunch of different KPIs that SREs actually measure. And what you should do is you actually measure it per group. We actually did this at one of the companies I've worked at. We essentially gave a score of how DevOps mature they were, right?
Hmm.
And for our more DevOps mature groups, we allowed them to be a little bit more risky and a little bit more pushing the edge. Their failure rate was a lot lower because of it, and they were able to recover faster. And so we allowed them to be a little bit less rigid with our policies because we knew that they could handle it, versus other groups that were a little bit less DevOps mature. We kind of forced them into a specific workflow and a specific framework that they had to follow so that they didn't accidentally bring down production or something like that. It is a good approach to kind of a DevOps transformation of a company.
Yeah.
Complete side tangent,
No, no,
but
no, you're right though. And the whole point that I wanted to bring up here, and maybe this is actually said and I didn't interpret it this way, but they say some teams are just starting while others have built robust self-service platforms with
yes, they do.
guardrails.
Yeah,
And that's usually how adoption happens, is that one team realizes the value, they go ahead, and ideally they lead the other teams, or unfortunately force the other teams to go in the same direction. The leadership will go and say, that team's making it work. you guys should go and follow, and then the rest of the organization follows. So next section, when does IAC orchestration make sense? IAC orchestration isn't for teams just experimenting with automation. If you're still figuring out Terraform basics, you don't need orchestration yet. But once you're in adopter territory, you start seeing patterns. Some good. Hey, we can spin up entire environments in minutes. Some not so good. Why does every team have a slightly different way of provisioning infrastructure? At this stage, teams often misapply DevOps best practices to IAC. They treat infrastructure like application code, running it through general purpose CI/CD pipelines. And for small scale deployments, this might work. But as complexity grows, you hit a wall. IAC is not like application code. Application deployments are stateless. Today's build doesn't care about last week's. Infrastructure is stateful. Your Terraform config today includes the database you created last year, the DNS entries from last month, and the load balancer from last week. That's why treating IAC like app code fails. It's why infrastructure requires dedicated orchestration, just like databases have schema migration tools. So if you're an adopter trying to become an optimizer, orchestration will give you the most significant boost. And if you're aiming for leader status, it's a must-have. Do you think this person is selling IAC orchestration tools?
Hold your horses.
Yep.
Calm down. I wholeheartedly disagree with this entire paragraph. This is where it gets choppy. So, no, I think the author makes some really great points in here. But here's my issue is his statement saying application code's stateless and infrastructure's not stateless. I think he hasn't had the opportunity to work with cloud infrastructure that can be stateless.
Mm-hmm.
I do agree that is a pitfall that a lot of companies fall into. They assume infrastructure is stateful, and so they make all infrastructure stateful, which means it makes it really hard to automate. But I completely disagree that infrastructure can't be stateless, just like I disagree with his statement that all applications stateless. He hasn't worked with the plenty of companies I've worked at where every single application they had was very stateful. And even things like using Redis, that's supposed to be a stateless database, was used as a very stateful, needed to be backed up all the time database. And I think that is where the power comes in, is you need to split out your things that can't be stateless from the things that can be stateless. And so my perfect example is, just like you mentioned, databases. Yes, very much agree that has to be stateful. You keep that separate. You keep that in a completely different piece of Terraform code where things can't go wrong, or it's a lot harder to go wrong. Now, on the vice versa, Kubernetes cluster. I have seen a lot of companies make a Kubernetes cluster very stateful, where to the point where they take an entire backup of the entire control plane because they can't lose any of that state. And that's where you went wrong. Kubernetes, by design, has a ton of open source solutions that allow it to be very stateless. For example, secrets. Why are you storing secrets in your Kubernetes cluster that's not somewhere else? External secrets exist. You can use external secrets, and especially if you're in the cloud, you store those secrets in Secrets Manager or SSM, and then you pull them in when your application comes online. Now your Kubernetes cluster is stateless. Now you can take that application and run it in 20 different Kubernetes clusters in the same AWS account. Doesn't matter. I can blow away one of them, bring it back up. Not a problem at all. Now all of a sudden, you have yourself some automation that's really easy.
I think, to your point, basically the high level point that he's making here, that application deployments are stateless, which is, like you say, totally overblown. Or at least, I mean, ideally they should be. Ideally, applications should be stateless. But saying infrastructure is stateful, I mean, a lot of application deployments are stateful, and you can have infrastructure that's stateless. So if you're saying that IAC orchestration is really good for stateful things, I really have no problem with that.
Yeah.
But you can have all of your app code and all of your infrastructure in CI/CD if it's all stateless, right? I think that's the goal that a lot of software has moved towards, is make everything as stateless as possible. Now, I understand that is not the case for a lot of companies, or even single apps within the company, right? People say this thing has to have this thing, this has to have a database, and we're not going to decouple it in any way and whatnot. But I think that the starting assumption here, like you mentioned, is a bit wrong. Let's see where he goes. So, two big misconceptions about IAC orchestration. I've had a lot of conversations with DevOps leaders who hesitate on orchestration. Usually, they bring up one of two concerns. One, why can't we just use our existing CI/CD tools? I get it. Why add another tool when you already have Jenkins, GitHub Actions, or whatever your team prefers? But here's the thing. CI/CD pipelines weren't designed for infrastructure. They're optimized for quick, stateless deployments, not for managing dependencies across thousands of interwoven cloud resources. Teams try to brute force through this by bolting on custom scripts and workarounds, but eventually they run into race conditions, drift, or, worst case, accidentally take down a live production database. The reality is that once you reach a certain scale, you need an orchestration layer built for infrastructure, not application code. The second big misconception: won't this create lock-in? No one wants to be trapped in a proprietary ecosystem. That's why the best IAC orchestration solutions use open standards, storing Terraform state externally, using Docker for execution environments, and leveraging Open Policy Agent for governance. Lock-in happens when you build a fragile in-house solution that only your team understands. Good orchestration reduces lock-in by standardizing workflows, not boxing you into a specific vendor. Thoughts?
I mean, if we rephrase this and say for your stateful infrastructure, then I very much agree with everything that this person is saying. I replaced the word infrastructure with stateful infrastructure or stateful applications. Now, I'm going to assume that this article is probably trying to sell some sort of tool that only works with infrastructure, which is why he's probably being very targeted towards this infrastructure type stuff. And so I'll give that to him. I don't know. What are your thoughts?
No, I'm also in the same boat. I want to talk about this one with this create lock-in. And I do think the statement, lock-in happens when you build a fragile in-house solution that only your team understands. I think that's fair. There's a lot of people who they want to go and introduce some new tool or some new way of optimizing their system. And what happens is people say, well, can you handle this weird case that we have?
Mm.
And you say, well, no, how do you handle that case? And they're like, well, you don't want to know. We don't really understand, but it all works.
Yeah.
Right. And I do think that a lot of companies end up having that fragile in-house solution. I think the way you get around those comes down to building your applications differently. And I understand for a lot of companies, that's a rewrite that they're not willing to do. And so then they're going to be looking into other solutions for solving their problems.
Yeah. No, I totally agree with that.
So the good orchestration reduces lock-in. I can believe that. I think if they have a tool that reduces the muck that a company's made, then that's not really lock-in. Although maybe it is lock-in, right? I think he dodges the question a little bit because when you choose AWS or Azure or Google Cloud to do all your cloud infrastructure, a lot of people, they're basically building lock-in. It's really hard to switch out once you have one of these tools.
Actually, I have a really good story about that. There was one company I worked at where the CTO was very adamant on building cloud agnostic everything, all the way up to infrastructure. Our infrastructure was on Kubernetes, and our automation scripts that we used or in tools we used had to be cloud agnostic. So we could spin up the same exact Kubernetes cluster in a different location. There was obviously areas that can't happen, but he wanted to be as cloud agnostic as possible. And he would track what he would call the exit cost. What would be the cost if we had to rewrite our entire application and all of our infrastructure and move it from AWS to GCP?
Mm-hmm.
And the reason why he did this was because he was afraid of vendor lock-in and the vendor gouging him on the price. And if at any point in time that they tried to do that and he looked at the price that they were gouging was more expensive than the exit cost he was tracking, he would pull the trigger and move everyone out and into something else.
I like that concept, But
It's a
what
really
did it
interesting idea.
how much time did it take? That seems like it's like complicated.
These weren't
I almost want his tool. If he can make a tool.
well, he didn't have a tool, but could you imagine actually, you know what? Might be giving away like an idea of a project we could work on. I don't know if I want to say it, but with AI today, technically, if you give it the ability to read all of like your infrastructure code and application, have it calculate is there a one-to-one replacement with another AWS cloud tool, or would they have to rewrite it? It could probably give you a very realistic idea of a budget of how much development time it would cost to actually move it. Because that's all he did, right? And of course, his wasn't super accurate, but he was technical enough to be able to read the code and understand what tools they used and where the pitfalls were and what we couldn't move, right? Things like
Honestly, because it was just for him or just for that company too, it only needed to be 80% there. It only needed to be a ballpark to get it good. I like that concept. You know, if somebody else wants to go and do it, or hey, we could do it.
This is a project idea. I don't know.
Oh, well, okay. Well,
maybe I'll cut that part out. I don't know.
Yeah, we can leave it in the show if we think we just won't have time, and that'll be something for somebody else who's very ambitious. So, next section is avoiding the common IAC traps. Even with orchestration, DevOps teams fall into two common pitfalls. 1. The IAC monolith problem. Some teams consolidate all of their infrastructure into a single massive project. That sounds efficient, right? One place to manage everything? Wrong. Monoliths become impossible to manage at scale. They take forever to sync, get throttled by cloud APIs, and eventually crash. A common example is a Terraform monolith, also known as a Teralith. It sounds like a good idea at the start, but it becomes complicated and troublesome as your infrastructure grows. But the opposite extreme, breaking everything into tiny, fragmented IAC projects, is just as bad. It adds too much overhead and makes dependency management a nightmare. The key is finding the right level of modularization for your team's needs.
I mean, yeah, I'm back on board. He's convinced me. Whatever he's selling, I'm buying. He's so dead on. This is the most dead on statement I have ever seen.
Ironic, because I have a couple problems with it.
Oh gosh. Well, so what I will have to say is the amount of companies I've been at that did create a monolithic Terraform repo. When you do like a Terraform apply, the first thing it does is it tries to sync everything. Then after it syncs everything, it tries to do a three-way diff, and then it calculates that diff to decide what's going to actually change based off of your changed code. The sync process, which is querying all of the APIs, let's say in AWS, to grab the currently running in those repos would take 45 minutes.
God.
And to this guy's point, exactly what was happening. They had so much AWS infrastructure in that Terraform repo that it was essentially DDoSing AWS, and AWS started rate limiting them. And so the amount of time it would take just to sync, that was just sync what the currently running stuff, because then it had to do the comparisons, and if those and Terraform, at least at this time, was also written very poorly. So then to do the diff between what was currently running and what you wanted in code, if you had a massive monolithic repo like that, easily took another 15 to 20 minutes. So you're looking at an hour long
Terraform apply.
And that's what ended up happening at our company in our CI/CD pipelines. The Terraform apply, the diff alone would take so long that the AWS credentials would time out because they were only set to an hour, and then the pipeline would fail, and we would have to rerun it again, hoping it didn't take an hour long. Until we obviously changed the credentials to be 8 hours, but I mean, it was just like, it was terrible. It was absolutely terrible. So like the scar of this one paragraph is so deep. I'm just like, yep, I'm on board with this guy, whatever he has to say.
That's totally fair. I think that there are some times where, like, you know, monolith versus microservices in like app design. Forget cloud infrastructure.
Yeah.
There are times where, you know, people say, oh no, we got to break this out into separate things. And then it just becomes very confusing managing all the interdependencies. And they, in terms of working on it, right? People have to understand 30 projects instead of understanding 3, right? I think there are times where a monolith is appropriate. But Terraform is definitely a place where you have to be very careful.
Yeah.
And I
I mean,
understand with managing infrastructure as a monolith, it's like you want to be able to provision it all at the same time. How do you do that? Right? You want to recover from zero. How do you do that? There needs to be orchestration. So I guess coming back to this, like I'm kind of coming around to where he's leading
yeah.
us to.
Yeah. I mean, I hate monoliths. I'm actually the guy on the other extreme where I will literally create a repo for like 20 lines of code if I think it's a separate service that should not be touched. And I agree, my extreme is also terrible. I definitely agree with that. But my big issue with monoliths is you're 100% correct when you say it makes development easier. But it makes operating it so much harder, deploying it so much harder, testing it so much harder. And so that's my big problem with monoliths is it's making the life of a specific job function as easy as possible and passing off all of the hard stuff down the road and kicking the can down the road. And that's
Mhm.
why that's why I'm like so against it. Is that I think the job of anybody in the company should be equally as hard. You should not try to optimize one specific job function because when you do that, you create constraints all the way down the line.
Mhm.
And so releasing to production just becomes even worse, not better, by improving the life of one specific job function. It actually does the opposite effect, you know?
Ideally, you architect it in the beginning so that your thing is in digestible parts and that have clear boundaries and all the stuff we love about microservices,
Yeah.
right?
Yeah. Well, he says it. The key is finding the right level of modularization for your team's needs, for sure.
So the first, that was avoiding the common ISC traps. One was the ISC monolith problem. Two is overly prescriptive versus Wild West. If you're rolling out self-service infrastructure, you need guardrails, but too many restrictions frustrate developers, forcing them to constantly ask DevOps for special exceptions. On the other hand, too much freedom leads to chaos. Teams deploy infrastructure in entirely new ways, security vulnerabilities creep in, and costs spiral out of control. The sweet spot? Provide open-ended building blocks with built-in policies for security and cost control. Yeah,
Yeah.
nothing I disagree with. So where do we go from here? Consider these steps to make forward progress. 1. Assess your current stage. Are you an adopter struggling with standardization, an optimizer working through governance challenges? Be honest about where you are. 2. Identify your roadblocks. Are you dealing with infrastructure bottlenecks, compliance headaches, or constant rework? Prioritize what's slowing you down. 3. Adopt a gradual approach. Don't try to build the perfect ISC setup from day one. Start small, iterate, and adjust as you go. 4. Invest in orchestration when you're ready. If you're hitting scaling challenges, now is the time to move beyond basic automation. At the leader stage, automation isn't just about speed, it's about control, security, and developer enablement. That's where the real ROI comes in. Yeah, I mean, you could honestly take these 4 steps here, and I mean, it reminds me a lot of the Phoenix Project.
Yeah. Yeah, it really does.
And a lot of this does come down to the gut. Where are you currently? What are your roadblocks? Do this piecemeal. Invest in orchestration or any other tool at the right time.
Yeah. I think this section's really strong. I really like it because it can be really hard for people in our roles, DevOps, SRE, platform engineering, these types of roles. You're basically riding on a bike with your hair on fire over a tightrope at all times, at all times. And so it can be really hard for you to pull your head up and really look at a roadmap or even just look at where you are. Where do you need to go? And I have seen these teams fall into this pitfall where it's like they get stuck kind of in a specific stage And they don't ever move out of it because they never do this. They never sit back and actually really analyze themselves and where they are and why they're stuck there. So these 4 steps, I think it's very strong ending to this article for sure.
Yeah. Oh, but we still have the final thought.
Yeah, let's move on to the final thought.
Final thought, the speed control paradox. One of the most interesting findings from our survey was what we call the speed control paradox. Teams early in their IAC journey focus on speed, deploying infrastructure faster. But as they mature, they realize the real challenge is control, governance, compliance, and security. The best teams, the leaders, balance both. They build fast, but with governance built into every progress. They enable developers while keeping security and compliance in check. And at the end of the day, that's the goal.
Sure. There's actually a lot to this paragraph. What he says here is the best teams balance both, but that's not majority. What I actually find in a lot of the places I've worked at, they recognize that the infrastructure team or the DevOps team or the SRE team, whatever you call yourself, is moving way too fast. And there's no control, and there needs to be control. What do? They overcompensate. They introduce control management teams, and they introduce ServiceNow, where then you have to track every single change you make. And it completely destroys innovation. It completely slows down your fast movers, your disruptors, and it's an overcompensation. And to this guy's point, it's not a balance. They go from one extreme, which is moving so fast that they're able to fix things in production less than an hour after it's detected by Datadog or what have you. But the problem is companies go, wait, but we shouldn't be failing like this. They don't look at how fast it was they were to recover. They look at how many times they failed, and they freak out. They're like, oh my gosh, these are failures. We shouldn't even be having these. How do we stop failures from happening? And that's when they introduce change management. And that's when it completely goes the opposite direction and completely stomps out any progress you've made as a DevOps guy. So I honestly, again, this last paragraph, so strong. And I think there's not enough emphasis on this when he says the best teams, the leaders, balance both. That is so important. And if you are a listener in a company that's at this point where you guys are moving too fast and people are freaking out, it's really important to take a step back and realize failure is not the problem. Failure is how you innovate. The issue is recovery times. The issue is very important KPIs. And you need to make sure your SREs are tracking that.
Yeah, it's really interesting. I want to see the data that they have, right? I think they've found some really good conclusions from it.
Yeah.
And I also think that it's really interesting that he decided to end on this speed control paradox thing.
Yeah.
Because in a lot of ways, it's almost a little bit different from everything else, right? That's why he talks about it as like a final thought, right? But it was so important that he had to bring it up. He was like, I can't let this article be done before I talk about how companies have this problem of fast deployments versus sort of secure deployments.
Yeah.
Marcin Wazinski is the co-founder and chief R&D officer at Spacelift. He is also a co-founder of the OpenTofu project, which, as we know, is the sort of Terraform replacement, if you will.
The better Terraform open source replacement.
Yes, yes. He started his career as an SRE for Google, then moved into software engineering at Facebook.
That's
an entrepreneur at heart. Wazinski went on to start several companies. So
for our listeners, Google birthed SRE. The fact that he started his career there, it explains a lot of what we were reading through this and kind of what I was saying, which is it's really important for an SRE to do this, an SRE to do that. It explains a lot. This person has a ton of experience doing this every day and understands what it's like to be an SRE trying to battle a lot of these problems. So I find that really interesting. And that's the thing is that's when you were an SRE at Google, these type of KPIs, they really did try to hammer them into you.
Yeah.
Yeah.
I think it's, I did mention the entire time we were reading, like, what is he trying to sell? I do think it's interesting that obviously he mentioned Spacelift. And that's the company he works at. And the fact that they did the, I believe they did the survey or they commissioned a survey that provides a lot of their information, but they don't actually go and overly sell their product. Just kind of lead people in that direction. And it does make me want to look into Spacelift more and see what they're doing. and how they might solve some of these problems.
Well, my big problem with the article is he never really explained what IAC orchestration is. So
Yes,
I
yes, right.
I'm on board, man. I want to try it out, but what is it? How do I even start?
Well, that's a different episode.
Yeah, and that's the thing is like I kind of Googled it, and my response is Kubernetes, Docker Swarm, Red Hat, Terraform. That's not IAC orchestration tools. Those are containerized orchestration tools, if anything. And
Right.
Terraform, like he mentions Terraform, is an orchestration, which I completely agree with. So it's definitely something to do more research into, and maybe take a look at Spacelift and give it a try. We're not sponsored at, but
And with today's sponsor, Spacelift,
yeah. I could.
provision with a single automated workflow.
So what's funny is I could actually insert sponsorships after it's recorded through like our technology. So like, how funny would it be if I'm like, we're not sponsored, and then it like phases out and thank you for joining us, our sponsor today.
God, we'll have to work on that in the future.
Well, Josh, I actually find that article was quite enlightening. What do you think?
I think I have a lot to think about.
For sure.
I hope
For sure.
this has given me a couple new things to think about in terms of how we think about infrastructure automation.
Tune for a future episode where maybe we explore the vendor tool.
Sounds good. That was our containerized conversation. Have a good night.